Okay, let's take a look at the homework from last Friday, the one that I didn't have a video for, but here we are. So this is going to be due this Friday. Thanks for being patient with having a sub, but we got to figure this out, all right? So we did both of these quote-unquote squares in class together. So let's take a look at number 38. So if you don't have dot paper, that's fine. I handed out dot paper Friday, but if you don't have dot paper, you can try to recreate it on your own. Sorry about that. Or you don't necessarily have to draw out the square. So let's take a look at 38. So 38, consider the segment. So a line segment starts and ends at a point labeled with the letters of the segment. So from A to B. It says on dot paper, draw a square with side AB. What area is the square? So in order to draw this square, we need to see that section right there, all right? We need to take that diagonal and go from 1 point over 1, up 1, up 1, over 1, over 1, down 1, down 1, over 1. Okay, those are the four corners of that square. What is the area of the square? The area of this square is that little rectangle, triangle, is half of a square. Here is another half of a square, so that's 1. Here's another half of a square, that's 1.5. And then here is another half of a square, that's 2. So when I say half of a square, I'm talking about this square right here. That's a square unit. So this is half of this. Okay, so we know the area of this, area equals 2. It says use a calculator to estimate the length of segment EB. So remember, even using a calculator, estimating the side length of a square whose area is 2, side length is square root of area, side length is square root of 2. It's still an estimate because, hopefully you know the answer, okay, non-perfect square roots are irrational. So even if we break out a calculator, it is going to have to estimate the answer for us. So here is a calculator. I take 2 square root. It is 1.414214, and then that decimal continues forever, never repeating a pattern, never stopping. So this isn't side length equals, it's side length approximately equals, okay? And it approximately equals 1.4 units. All right, so that's A and B. Let's take a look at this segment on the right. I'm going to redraw this one. This one's right here. Okay, I know because I go over 2 dots and up 1. So I'm going to finish off this square by following that same pattern. 2, 1, 2, 1, 2, 1, 2, 1. Those are the 4 corners of my square. Okay, now if I'm breaking down, again, we did this one in class. If I am trying to recognize the area of that rectangle, that triangle, it's a height of 1, a base of 2. 1 times 2 is 2, divided by 2, because it's a triangle, is an area of 1. We can look at that visually by saying, hey, this whole rectangle is 2 square units, and this triangle is half of that. So that means it's only worth 1. So we have 1 there, 1 there, 1 there, 1 there, and then 1 in the middle. So the area for 39, answer A, area is 5, we'll say units squared. We've got our units up here. Area equals 2 units squared. Okay? And this is so then it says use a calculator to estimate the length of segment CD. So this is segment CD. It's a straight line. It's a line. Starts at C, ends at D, therefore it's a segment. Okay? That includes those points. Anyway, we'll get to that. Use a calculator to estimate the length. Again. Clear. 5. We're going to take the square root. You should know this is a little bit over 2 because 2 squared is 4 and we're looking for 5. So it's going to be 2.1, 2.2. There we go, 2.23. So B, side length is square root of 5 exactly. And square root of 5 is approximately 2.3 units long. All right, so that is 38 and 39. Let's go ahead and take a look at 40. So 40, this is tough because you don't have dot paper to draw all over this. One of my students said today that they copied this down onto paper and went ahead and counted everything out there, right? Find the area and side length of this square. Ooh, how are we gonna find the area? Okay, so one, we could try to go in and find every little full square and count it. Ugh, that's not great. We could take the area of the whole big square, subtract out the area of these triangles, and that would leave us the leftovers in the middle. Totally could do that. Another thing we could do is to try to identify our right triangles inside of this item, inside of this square, excuse me. But we might still end up drawing in our book. And I don't really like drawing in our book. So the best way to do this is the subtraction method I just mentioned. Let's, without drawing in our book, let's figure out the area of that middle part, okay? First, we need to figure out the area of the big square, and we can do that just counting. 1, 2, 3, 4, 5, 6, 7, 8, 9. We know it's a side length of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a square, but I had to double check. 9 squared is 81. That is the area of the big square, okay? Unit square. And we're going to take away 4 triangles, all right? So this triangle right here has a height of 1, 2, 3, and a base of 1, 2, 3, 4, 5, 6. So 3 times 6 is 18. Half of that is 9. So we're going to subtract away 9 for that triangle, 9 for this triangle, 9 for this one, 9 for this one. If you did 4 times 9, that's awesome. Okay? So we're going to subtract away all those 9s. All right? Now I'm going to simplify this by subtracting away 4 times 9. What's the best way to do that? No, I'll just do it one at a time. So 81 minus 9 is 72. Minus 9 again, 63. Minus 9 again, 54. Minus 9 again, 45. So that means the area of the square in the middle is 45 units squared. All right? Now I get to cheat a little bit. I get to draw on this thing. So I'm going to draw this here. I know that's 9 square units. I know that's 9 square units. I know that's 9 square units. And I know that's 9 square units. That is 1, 2, 3, 4, 5, 6, and a height of 3. Bam, I know that's 9. 4 times 9, 36. Awesome. Plus one more 9 in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9. That gives me 5 9s. That's also 45. Okay? I don't want you to draw in the book. That's why I showed you the other way. Cool. So this square. Find the length of every line segment that can be drawn. Oh, wait, that's just it. So find the area and side length of this square. Area is 45 units squared. Side length is square root of 45, which is a little bit less than 7. Let's check this out. 45 square root, 6.7, approximately 6.7 units. Okay, that is problem 40. Okay, problem 41. Find the length of every line segment that can be drawn by connecting dots on a 3 dot by 3 dot grid. Oh, goodness. So, find the length of every line segment that can be drawn by connecting dots on a 3 dot by 3 dot grid. So you might have to, you're going to have to draw your own 3 dot by 3 dot grid. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 3 by 3. Okay, So let's go ahead and skip 41. If you tried 41, kudos to you. Show me your work, I'll give you a star. Because this is pretty tough, all right? So find the line segment, the length of every line segment that can be drawn. We have a length of 1. 1 can be drawn. We have a length of 2. 2 can be drawn. We do not have a length of 3. Why not? Because once we start going diagonal, the rules change. Remember? So if I go diagonal here, oops, that's horrible. Here, well then I'm going to end up with a tilted square. And then I know that is the square root of 2 units. If I were to draw this out like this, like this, like this, this little line right here is the square root of 2, right? Because that square is an area of 2. The side length must be the square root of 2. Awesome. Well, if that's the square root of 2, if I double it, that is 2 times the square root of 2. So right now we have 4 line segments, okay? But we don't have to just go straight diagonal. We could also go so diagonal there. We could shoot straight across here, okay? That is a son of a gun. So we're going to have to come out 1, 2, and over 1. 1, 2, and up 1. 1, 2, and over 1. Let's back again. And we should recognize this from our classwork. This is an area of 5. Here's a half. No, I'm sorry. That's 1 unit. So that's a rectangle of area of 2. That's half of it. So that's 1. Here's 1. There's 1. There's 1. And then 1 in the middle. So that's an area of 5. So if that's an area of 5, that side length must be the square root of 5. Now, if I try to find another line to draw, I can't. Every other line is going to be a version of the others. So this is 1, this is 1. If I go up diagonal, that's the same, square root of 2, square root of 2. If I go all the way across, that's 2 times the square root of 2. If I draw this line, that line and that line are the same line. I'm pretty confident I cannot draw any other unique lines on a 3x3 dot. Okay? But we have all those different lengths that we're looking at up there. Okay, 1, 2, and then the longest length we have is the square, is 2 times the square root of 2. Alrighty? This is the square root of 5. 2 times the square root of 2 would be a lower one. If you were able to do this, awesome. Again, nice star. Let's go ahead and look at 42. Final question. Consider this line segment. The question is actually underneath the problem. It says, express the length of the segment using the square root symbol. The area of this, these are some tough questions, guys. If you're able to pull these off, good. If you're following along with the video, good job being persistent. If I were to redraw this up here, consider this segment, you must find the area of this, the square root. So let's see, it's going up 2 over 1, 2, 3, 4, 5. So then you have to go over 2 and then down 5. Oof. I'm not a fan of 42. I'm not a fan of 42. Let's see. This is a tough one. You're going to need dot paper for this one. You're going to need dot paper for this one. So let me switch back over to my dot paper and steal it. And I don't think this dot paper is going to be enough. Okay. So we got this guy. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Squish them over to the side. 6. 6 is out here. And it's down 2. Over 6. And then we go out 2 more. 1, 2. Down 5. 1, 2, 3, 4, 5. Down 2, 1, 2, 5, 1, 2, 3, 4, 5, and then up there. And so this is really poorly drawn. And from this drawing, I'm just sketching this out. I don't have a lot of strategies. I don't have a lot of strategies for figuring this out. I just don't. Okay, so we would have to use the Pythagorean theorem for this one, or I had to have given you a full dot sheet of paper. So my mistake, I needed to give you a full dot sheet of paper for this homework. So if you got to this part, you're doing good. You're doing good. So let's not worry about 42 until we get some dot paper in front of us. All right. Hold on 1 sec. Maybe I can. Let's see. That's up 2 over 1, 2, 3, 4, 5. Let's see if maybe I can do it just since we're here. Got this guy. Let's get a background in there. Okay, this, so we start here. Start here, up 2, over 5, 1, 2, 3, 4, 5. Over 2, down 5, 1, 2, 3, 4, 5. Down 2, over 5, 1, 2, 3, 4, 5. And here, we have this shape. Okay. And here in this shape, we should recognize that we have that right triangle, that right triangle, that right triangle. There we go. And we have 9 in the middle. We have 9 in the middle. Oh, this looks really familiar. This can't be right. One, 2, 3, 4, 5, down 2. 1, 2, 3, 4, 5, down 2. Maybe it is. All right, so we have 9 for the square in the middle. This is a height of 2, a base of 5. So that means the triangle on top is 5 square units. Triangle on the right, 5 square units. 5 on the bottom, 5 over here. And then that gives us 29 units squared, which means that's the area. Side length will be square root of 29, which is in between 5 and 6. So it is going to be 5 point something. So when it asks you what 2 integers is the side length in between, it's between 5 and 6 because the square root of 29 is approximately 5.4. Okay, I knew that because 29 is larger than 5 squared, which is 25, but it's smaller than 6 squared, which is 36. So that concludes the homework, guys. Sorry for assigning something so tough. Hopefully the video helped out and you're learning something from the explanation. And thank you for pushing through and being persistent and trying to figure it out on your own. Talk to you soon.